My name is Nicholas McInnis, and today I am going to show you the ExxonMobil Torrance Refinery electrostatic precipitator explosion in Torrance, California. This incident happened on February 18th, 2015. The overview of the accident. On the morning of February 16th, 2015, ExxonMobil went into a safe park mode, which is a standby mode which turns the flow of hydrocarbons off. Two side valves connecting the reactor and the generator are closed to ensure a catalyst barrier is maintained. Steam is increased to ensure no hydrocarbons are flowing back. However, one side valve became eroded over 6 years of operation, which caused the catalyst in the reactor to fall through the side valve into the regenerator. This caused a direct pathway for hydrocarbons to flow between the reactor and the regenerator. On February 17th, a meeting was held which brought management to use a variance report from 2012 to install a blind in one of the expander's flanges. However, this failed due to the steam arising from the expander. During this time, the flow of steam reduces in the reactor. The variance from 2012 did not evaluate if the flow was efficient, which caused a flow of hydrocarbons into the reactor due to the decrease in steam. Furthermore, light hydrocarbons from a separate unit had flowed through a leaking heat exchanger into the main column, causing pressure inside. As supervisors had the alert of hydrogen sulfide, they decided to evacuate personnel and then increase the steam. However, it was too late to increase steam as the hydrocarbons went into the fluid catalytic cracking (FCC) unit towards the electrostatic precipitator (ESP). The ESP does not turn off during standby mode, which caused the explosion. The accident was caused due to the lack of operating procedures and not performing a correct hazard analysis. In this illustration, the video shows how the ExxonMobil refinery in Torrance, California works. All the way up to about 2 minutes and 20 seconds of the video, it shows what the ESP is, what the FCC is, how everything works together to get the final product. After the 2 minute 20-second mark, it shows you what went wrong, and it shows you how the valve was eroded and how the supervisors and management determined how a 2012 variance report was used, and a hazard analysis was not done to decide if anything else was a problem, which ended up being the result of the problem and the explosion. So the root cause of the 14 OSHA elements was operating procedures. The Chemical Safety Board final ruling has in there that one of the final rulings was operating procedures. Operating procedures is when OSHA inspectors want to see that the companies have plans during a time of prior before an explosion. Now, the reason why operating procedures was the final rule is because Exxon used a similar operation filed back in 2012. This was the issue because they did not file a specific and sufficient hazard analysis. They used a variance report back in 2012, an assumption that was the reason why operation was not starting back up. Exxon operated the FCC unit equipment beyond its predicted safe operating life as well, and the failure of equipment allowed hydrocarbons to reach the ESP. Exxon also failed examining operating equipment. Now, the failed operating procedures in the video is around 3 minutes 25 seconds, as it shows how Exxon did not fully check their equipment, which one of the biggest things was the erosion of the valve that had been in production for 6 years. This ultimately was the root cause, as it allowed catalyst to flow and eventually let all the hydrocarbons in as they turned off the steam. So the lesson to be learned at the ExxonMobil facility in 2015 can be taught from the whole industry. Just because a similar failure of operating equipment happened before does not mean it's the same reason in which is causing the failure. A full analysis must be conducted before assumption. Exxon failed to conduct a full analysis and used a similar report from 2012 which did not evaluate operating equipment and procedures. If Exxon would have fully evaluated, they could have possibly found the eroded valve which caused the flow of hydrocarbons. This lesson learned is that when operating is stopped, a full investigation of the operation must be conducted to ensure nothing else is at stake of causing the interruption of operating. This is the works cited. It can be found at Chemical Safety Board.